Okay, in this video I'm going to go through an IGCSE past paper exam question. This one's going to be looking at logic gates and logic circuits. Now this comes up quite frequently, practically every exam session. I mean, I can't say absolutely with 100% guarantee that there will be a question like this, but if you look through past papers historically, a question similar to this will occur, will crop up in your examination. So it's well worth practicing these skills, particularly with the development of logic circuits. Okay, so starting off, we're looking at logic gates, and they've got descriptions of the logic gates, and you need to identify the logic gates and then complete the truth table for each of those logic gates. So the first one, the only time the output is 1 is when both inputs are 1. Well, so that's clearly an AND gate, okay? So it's because A and B have to be 1 or high or positive to produce a positive output value for X. So in this case, the truth table, then going to the truth table, 0, 0 will produce a 0, 0, 1 will produce a 0, 1, 0 will produce a 0, 1, 1 will produce a 1. Okay, so the second one, not quite so obvious, but the output is 1 when both inputs are different. So when both inputs are 0, we get a 0, but also when both inputs are 1, we get a 0. So it is only when A or B are 1 do we get a positive output. So I've already completed the logic circuit there. Well, that is an XOR. Okay, an XOR gate. Sometimes you might see that written as EOR. Okay, either one is correct and either one will get you that mark. Okay, and finally, the only time the output is 1 is when both inputs are 0. Okay, so here this is actually a NOR gate. Okay, so this is NOR, and when both inputs are 0, we get 0, 0, 0. So we only get a positive output when both inputs are 0. And if you think about this, if it was an OR gate, when A or B were 1, and we invert that, which is what a NOR gate is, then we get the reverse of the results of an OR gate. And an OR gate would be 0, 1, 1, 1. The reverse of that, 1, 0, 0, 0. Okay, now then looking at the second part of this question, or really the fourth part of this question, we're to put together a logic circuit for the following expression. Okay, so we've got, now I always like to split these up. I think I find it easier to approach this like we've got one part of the expression and then the second part of the expression, and that is ORed together. Now, some people work backwards from X, some people work towards X. It doesn't really matter which way you prefer. Okay, so what I'm going to do is I'm going to focus first of all on this first part of the expression. Okay, not A or not B, and I'm going to construct the logic circuit for that first. Okay, so we are looking at not A or not B, and these are ORed together. So first of all, we have to invert A. So we put that through, let me change the colour so that looks more like, so we've got into, so we're putting through a NOT gate, we're inverting, okay, and not B, so again, not B, in through that NOT gate, that inverter, and they are ORed together, okay, so that's going into an OR gate. Now you can see, please forgive my rather dubious artistic skills. Okay, and then we're going to the second part now, which again, if we look at here, not C. So again, we are inverting the output from input C. So not Okay, and we'll see that the output from, let's change the colour there to blue, I'm just highlighting there, the output from this part and this part are going into an OR gate. So again, we draw in that OR gate, in the black colour, so into an OR gate. The output from our first part of the expression goes in, for output from our second part of the expression goes into that OR gate, and then that goes into the output X. And that's it. So what the examiner will be looking for is 1, 2, 3, 4, 5 correct gates for those 5 marks that are available there. Okay, so I hope that's been useful. If you do have any questions, queries, doubts, please pop them in the comments, and I will try and refer to them and answer to them as quickly as I possibly can.